Hi, we're Group 15, and we're going to be presenting our FYDP project, Tagr. Tagr is a data science productivity tool designed to abstract away the mundane experimentation tasks of the average data scientist. It accomplishes this by compiling a store of centralized results, serving as a single source of truth for experiment iterations. When data scientists are in the development stage of a model, they often iterate multiple times on one idea and need to document the conditions of the experiment. Often, this data is recorded by hand, which may lead to missing or incorrectly recorded data. Tagr is meant to be a standardized and automated solution to this problem.
According to a study by Crowdflower, data scientists spend more than 80% of their time wrangling data. This means that remaining time for data scientists to work on their models is limited and precious. Scientists must build their precious machine learning applications with limited resources. Clearly, there is a need to enable data scientists to develop models more effectively. For larger organizations, this benefit can be understood financially. As Gartner Research estimates, the average organization's cost of poor quality data is around 15 million per year. This is a significant amount, and it shows that implementing Tagr can have a positive financial impact by reducing the potential for incorrect data in making key business decisions.
Above is a graphic depicting the current data science workflow. The first step is acquiring the data needed from various sources. This data usually comes in the rawest form, and as such, a rigorous cleaning step must occur to make the data usable. After the data has been cleaned, a deeper dive into the data is usually required to become more intimate with the data before finalizing inputs. Some of the exploration techniques help the scientists understand the correlation between variables and the importance of variables on the outcome. This step is critical in determining the final inputs of the model. Lastly, the ML model is implemented, and results must be interpreted. The interpretation of the results is dependent on the type of ML problem addressed. Thus, a combination of technical knowledge on the ML procedure as well as domain-specific knowledge must be used. Tagr aims to seamlessly integrate with the current data scientist workflow. A key aid our tool will provide is the capability to log key metrics and data before a run. The first arrow shows an area of added functionality that will allow users to store the transformations and final variables used as inputs for the model. This leads to result steps in which the scientists, with the aid of this new functionality, will be able to iterate on their models as well as understand them better.
Tagr sits between the data scientist and the workflow. Tagr works by collecting experiment information from a data scientist's code. It then automatically persists this information to a third-party storage provider like Amazon S3. Then, whenever a data scientist is ready to revisit their work, Tagr will communicate with S3 to retrieve the results.
By streamlining and standardizing the data science workflow and simplifying routine tasks, Tagr abstracts away the cumbersome task of locating experiment results and writing custom retrieval functions each time. This gives time back to the data scientists to focus exactly on the true nature of the work, rapidly experimenting on ML models. Thank you for listening to our presentation.